Hello all, this is Gnansha Saramandrala, rule number 219518052, CACA section, and this is my COA concept video. And my topic is compilers. So, what's in compiler? In compiler is a program that translates source code written in one programming language, often called source language, into executable code in another language, often called targeted language. The purpose of compiler is to allow programmers to write program in high-level programming languages, which are easier to read and write than low-level machine language, and have the compiler translate the high-level code into machine code that can be executed by the computer. Difference between a compiler and the interpreter. Compiler versus execution. A compiler translates the entire program into the machine code before it is executed, while an interpreter executes the code line by line as it is encountered output. In compiler typically proceeds produces an executable file that can be run independently of the source code, while an interpreter produces output in real time as the code is executed. Performance. Compiled code generated runs faster than interpreted code, as the compilation process allows for the more efficient optimization of the code. Error detection. When compiler detects error it in the code before it is executed, while an interpreter detects an error as it executed each line of code. Probability. Portability. Com- the compiled code can be run on any machine with a compatible architecture, while interpreted code requires an interpreter to be installed on the machine. Memory usage. Compiled programs generally require less memory to run than interpreted programs, as compared to code is pre-optimized and does not need to be loaded into memory line by line. Development time. Development time of the compiled program may be longer, as the compilation process can be take longer than interpreting code in real time. However, compilers typically catch errors earlier, which can be ultimately save time in the debugging process. How does a compiler work? The compilation process involves several stages, each of which performs a specific task in translating source code into machine code. Here is a brief overview of a compilation process. Lexical analysis. The first stage of compilation process is lexical analysis, which breaks the source code into sequence of tokens. These tokens are basically building blocks of language and including keywords, operators, and identifiers. Next parsing. The stage is parsing, which takes a sequence of tokens and using a grammar to construct a syntax tree. The syntax tree represents the structure of the program and is usually to verify the program is syntactically correct. Next, semantic analysis. Once syntax tree is constructed, the compiler performs a semantic analysis to ensure that program is semantically correct. This involves checking variables that are defined before they are used, checking the type of consistent, and verifying the program conforms to the rules of the language. Code generation. After the program has been checked for the correctness, the compiler generates machine code that can be executed by the computer. This involves mapping. This involves mapping the syntax tree to instructions that can be executed by the computer's processor. And optimization. The final stage of compilation process is optimization, which attempts to improve the performance of the generated code by applying various techniques such as instruction reordering, loop unrolling, and the generation allocation. Types of compilers. There are several types of compilers, each of which is designed for a specific purpose or targeted platform. Here are some of the most common types of compilers. Native compilers. Native compilers generate mission code that can be executed directly on the targeted platform. These compilers are typically used to generate executable files for desktop or several applications. Cross compilers. Cross compilers generate code for targeted platform that is different from the platform on which the compiler is running. These compilers are often used to generate code of embedded systems or other specialized platforms. Just in time. JIT compilers. JIT compilers generate mission code at, at runtime just before the code is executed. This approach allows for the more efficient execution of the code that is frequently executed or dynamically generated. Ahead of time, AOT compilers. AOT compilers generate mission codes in advance and include in the application package. This approach allows to faster startup. Source to source compilers. Source to source compilers generate code in a different high level language than the original source code. This can be useful for the translating code between languages with different syntax for optimizing code for a specific platform. The popular compilers for different languages. GCC, GNU Compute Compiler Collection. GCC is a popular native compiler that supports a wide range of programming languages, including C, C++, Objective-C, and the Photon. CLAG. CLAG is a native compiler that is designed to compatible with GCC, but with better error messages and diagnostics. It supports same languages as GCC as well as some additional languages like OpenCL. Visual C++. Visual C++ is a native compiler that is included in the Microsoft Visual Studio. It supports C++ as well as C Sharp and Visual Basics. .NET. Java Virtual Machine JVM. The JVM is a just-in-minute compiler that is used to execute Java bytecode. It is included with a Java Development Kit (JDK) and supports a wide range of platforms. .NET Common Language Runtime (CLR). The CLR is a CLR Common Language Runtime is a just-in-minute compiler that is used to execute .NET code. It is included with Microsoft Visual Studio and supports a wide range of programming languages, including C Sharp, F and Visual Basics .NET. Yes. Challenges in compiler design. Compiler design is a complex task that involves dealing with wide range of challenges. Some of the key challenges in compiler design includes optimizing code. Of one primary goals of compiler is to generate efficient code that can be executed quickly. This requires optimizing the code at various levels, including instruction selection, register allocation, and instruction scheduling. Handling errors. Compiler need to be able to detect and report errors in the source code, such as syntax errors, semantic errors, and type errors. They also need to provide useful error messages to help developers fix these errors. Dealing with complex language features, modern programming languages, often including complex features such as object-oriented programming, generics, and closures. Compilers need to be able to handle these features correctly and efficiently. Generating code for multiple platforms. Compilers may need to generate code for wide range of platforms, each with their own instruction set and architecture. To overcome these challenges, compiler designers use a range of approaches, including stresses may as aspects of compiler design involve making trade-offs between different goals. such as code size, execution speed, and compile time. Compiler designers use heuristics and optimization algorithms to balance these trade-offs. Dynamic analysis. Dynamic analysis techniques such as profiling and feedback-directed optimization can be used to generate more efficient code by analyzing the behavior of the program at runtimes. Language specific techniques. Some challenges in computer design, such as handling complex languages features, require language specific feature techniques. For example, object oriented programming features may require different optimization strategies than procedural programming features. Collaborative development compiler designers often collaborate with the language designers and developers designers and developers to ensure that compiler is optimized for the specific requirements of the language it target platforms. It's importance of compilers. Compilers are essential tool in modern software development, and their importance lies in several key areas. Efficient execution. Compilers are responsible for generating executable code that can be executed efficiently on a given targeted problem. The optimization techniques used by compilers can significantly improve the performance of the generated code, making application faster and more responsive. The portability. Compilers make it possible to write code once and then compile it for the different target platforms. This allows developers to create software that can run on a wide range of devices and operating systems without having or to write separate versions of each platform. Error detection. Compilers can detect errors in source code such as syntax errors, semantic errors, and type errors. This helps developers to catch and fix errors early in the development process before the code is deployed to production. Language support. Compiler enable the use of programming languages that are optimized for different purposes, such as scientific computing, web development, and system programming by supporting multiple languages. Compilers allow developers to choose the language that is best suited for their needs and needs for their project. Development productivity. Compilers can automate the many aspects of the software development process, such as code optimization, memory management, and error checking. This can reduce the time and effort required to write the maintain high quality software, allowing the developers to focus on higher risk tasks such as design and architecture. Conclusion. In conclusion, compilers are essential tools for translating human readable programming language into mission readable code that computers can execute. Compilers perform a complex series of operations, including lexical analysis, parsing, and code generation, to produce an optimized and efficient code. Different types of compiler exist in various platforms and languages, and their design poses various challenges that require innovative solutions. Despite these difficulties, compilers play a crucial role in modern computing, enabling the developers to write a complex of software programming that is and efficient. The impact of compilers on software development and the history of computing is significant, and they will likely continue to shape the technological landscape for years to come. Thank you.